Students, hello students. Today we are seeing the VI characteristics of the power diode. So, what is the meaning of VI characteristics? So, VI is indicating the voltage and current. V means voltage and I is a current. This VI characteristics can be represented with the help of the graph. So, here we are having the positive x-axis, negative x-axis, positive y-axis and negative y-axis. So we are observing both forward biased condition of the power diode and reverse biased condition of the power diode. So we know the simple diode forward biased condition and reverse biased condition. So what is the difference between the simple diode and the power diode? So you can observe here in the first quadrant you are having a curve and your V0 is also you are observing where the breakdown voltage is going to take place, and at the reverse bias condition what is happening with the power diode. So as we know, when the forward bias condition, when you are going to increase the voltage slowly, so the current is also going to be increased. So here the current is not going to be increased exponentially as it is going to increase in the simple diode. So here linearly the current is going to be increased. Why the linearity in the increasing of the current is there in the power diode? Because we know there is n minus drift region which is there in the power diode, that is acting as a ohmic resistance. So ohmic resistance is acting as a obstacle to the current which is flowing from the anode to cathode. So the resistance is allowing the current slowly to pass from the anode to cathode. So but in the simple diode there will not be any ohmic resistance. Only a simple junction will be there which is immediately going to be break after applying a sufficient amount of the voltage. But in this power diode, when you are going to apply slowly the voltage, this drift region which we have seen in the structure of the power diode, that drift region is including the resistance which is acting as ohmic resistance which opposes the flow of the current. So we need to apply voltage more than the simple diode. So normally here in the power diode 1 volt is sufficient to break the junction. When you slowly increases the voltages, slowly the current linearly start increasing. So due to this ohmic layer or ohmic resistance, power diodes slowly they will allow the current to pass from the anode to cathode. The n minus drift region is lightly doped, hence it is acting as a low value internal resistance in the diode. So in the reverse bias condition, what happens? A very negligible amount of the anode current flows. Obviously we know when you give the reverse bias condition, that is positive supply to the negative, that is cathode, and negative supply to the anode, then it act as a reverse bias. When you give the voltage like this, the current, a small amount of the current will start flowing from the power diode, and this current is called as a leakage current. So when the reverse biased voltage increases above the breakdown voltage, the anode current increases rapidly. This rapid increase in anode current tends to large power dissipation. So in the diode, so what happens when the leakage current starts flowing and you are giving continuously highest voltage in the reverse bias condition, maybe the power diode it is going to be destroyed or damaged because it is not going to conduct in the reverse bias condition. So here diagram is shown, limit of the operating voltage in the third quadrant. You can observe there reverse biased voltage, when you start giving, the limit of the operating voltage will be somewhat, it is restricted. So when it will be crossed, when the reverse bias voltage sufficient whichever is required minimum, if it is crossed, then the increase in the current rapidly takes place. Due to this, the power diode may be damaged or destroyed, but in the forward bias it will start conducting. So we need a maximum voltage in the forward biased condition. So this is about the characteristics of the power diode.